Okay, we'll solve the next problem. So please refer question number 6, which I have given in the notes. Okay, so I'll read out the question once and I'll tell what is the difference between this problem and the other problems that we have solved. Okay, so design an RCC short square column to the following particulars. Okay, axial load is given, grade of concrete is given, length of column is given, and grade of steel is given. Okay, so in the other problems they used to give the area, that is either if it is rectangle they used to give B into D, or if it is circular column they used to give a diameter, whereas in this problem they have told only it is a square column and they have not given the dimension of width as well as the depth of the column. Okay, so other than the previous problem, in this problem we need to find the B and D of the column, that is we need to design like in the beams and all. First step we are finding thickness of the beam, then width of beam, and all the things that we used to by using the formula we used to write the section. Similarly here also they have given the question, the hint is it should be a square column, and B into D that we need to find, and also we need to find the ASC, that is the area of the longitudinal reinforcement, and also we need to find the diameter of the lateral ties as well as the spacing of the lateral ties. All the steps remains the same except we need to find B into D, okay, compared to the other problems. Okay, so refer problem number 6 which I have given in the notes. Okay, we'll write the data first. So what are the particulars which is given in the problem? Data, axial load is given 1200 kilonewton, so we need to multiply by 1.5 as I have told. So factored axial load, so we'll get 1800. Okay, sorry, 1800 kilonewton. Okay, then FCK is given 20 MPa. If Y is given 415 MPa, and unsupported length is given, that is 1.85 meters. As I told, if they give effective length, then it is no need to refer the table. If they are not given the effective length, if they given just the length of the column, then it will be a unsupported length. Okay, so here the difference between the other problem and this problem is, in the earlier problem first we were starting with the check for slenderness ratio. We were finding whether it is a short column or a long column. So in this problem the first step is the area of the steel. Okay, area of the steel. So this you need to remember only if they ask you to design the section along with the steel. Okay, so first step is the area of the steel. So ASC is equal to 0.8 times A into G. Okay, so if you don't remember, then PT is equal to 100 into ASC by AG, that is the area of the column. Okay, if you don't remember how you got this, then you remember this formula. Okay, so PT is the percentage of steel reinforcement. As you remember in the previous problems that we were solving, so it should not be less than 0.8% and it should not be more than 6%. Okay, so the least is it should not be less than 0.8%. so that's why we were taken minimum percentage of steel. Okay, AC is equal to 0.8% A into G. Okay, so next, area of concrete. Area of concrete. What is the formula for area of concrete? AC is equal to AG minus A into SC. Okay, so this is the difference between the other two. Okay, so AC is equal to 0.8% AG. This is the minimum percentage of steel. Okay, minimum percentage of steel which is given in the IS code, and area of concrete is AC is equal to AG minus A into C. Okay, so we'll substitute here AG minus 0.8 by 100, you will get 0.008 A into G. So 1 minus of 0.008 AG, you will get final answer 0.992 AG. 0.992 AG. Okay, so next we need to determine the size of the column. To determine the size of the column, we know the formula. PU is equal to 0.4 FCK into A into C plus 0.67 FY into ASC. If you don't remember, refer page number 71 of IS 456. Okay, substitute all the values here. PU means 1800 into 10 power 3. 0.4 into FCK means 20. Okay, AC that is the area of concrete that we have done, 0.992 into AG. So 0.992 into AG plus 0.67 into FY is 415. Okay, 415. Then A into SC that we have found out here in the first step, 0.8% AG. So 0.8% means 0.008 into AG. Okay, so we will solve it. 1800 into 10 power 3 is equal to 7.93 into AG plus 2.22 into AG. Okay, so final answer for AG that we will get is 177.23 into 10 power 3 mm square. 177.23 into 10 power 3 mm square. Okay, since in the question it is given as RCC short square column, please underline this square column. Square column means both B and D should be same. Okay, now we have got the gross area of the column as 177.23 into 10 power 3. Now for square column, both B and D should be same, right? For square column, we need to square root the value of A into G, because both B and D should be same, as I already told. AG means 177.23 into 10 power 3, you will get 420.99 mm. 420.99 mm. So we can provide, don't give the lesser, don't take 420 or don't take less than what you got the value, you can take more value. Provide a column size as 450 by 450. 450 by 450. Okay, so this is the step which is extra compared to the other three problems that we have solved. So I'll go back once, I'll explain once again. First we need to assume ASC 0.8% AG. Why 0.8% I have already explained here. So 0.8, it should percentage of steel should not be 0.8% and it should not be more than 6%. So I have taken the minimum percentage of steel. So AC is equal to 0.8% A into G. So area of concrete, we know the formula in the previous three problems also we have used this. Area of concrete is equal to gross area of column minus A into SC, that is AC, area of steel reinforcement. AC is equal to AG minus AC value, we have got it here, substitute here. So you will get 0.992 into AG. So our main aim is to find the AG, and we have known this formula. This formula is there in page number 71. Substitute all the values and find the value of AG. Okay, so since it is a square column, both B and D should be same. So I am square rooting the value of AG. You will get 420.99 mm. So select a higher number, 450 by 450. Clear? If it is a rectangular column, then at least one of the side they will give in the problem, so you can find the other side. They may give you a width or they may give you a depth. If they give you any other value, by using AG you can find the other section. Okay, so next, once this is done, the next step is same. Step is same. Check for slenderness ratio. Check for slenderness ratio. So why this step is done, I have already told to check whether it is long column or a short column. L effective by D, whether it is the D or whether it is B. In this case it is same because it is a square column, both B and D are same. Okay, so whether it is L effective or B or L effective by B, one and the same. Okay, which is equal to L effective. To find L effective you need to assume. Okay, so easier way is to assume that both the ends are hinged. Assume both ends are hinged. Assume both ends are hinged. Okay, so L effective, L is given 1.85 meters, so 1850 divided by B is B or D, both are same, 450 mm, so you will get 4.11, which is less than 12, so it is a short column. It is a short column. Okay, so next, check for minimum eccentricity. Check for minimum eccentricity. Okay, check for minimum eccentricity. E minimum is equal to, we know the formula, L by 500 plus B or D. Here also in this case, since it is a square column, you can substitute either B or D, both are same, by 30. If it is both B and D are separate, then you have to find longer direction and in the shorter direction. Okay, L by 500 plus B by 30, substitute the value. E minimum is equal to 1850 by 500 plus B is 450 by 30. Okay, if you do this, you will get the answer 18.7 mm. Okay, next find E permissible value, 0.05 into B, so 0.05 into 450. Okay, so you will get the answer 22.5 mm. So E minimum should be less than E permissible, then design is safe. Design is safe. Okay, next we'll go for design of longitudinal reinforcement. Design of longitudinal reinforcement. So AC we have already assumed it is 0.8% of A into G. So AC 0.08 into, we have already assumed in the first step, that is AC is equal to 0.8% AG. So AC is equal to 0.8%, that is 0.008 into A into G. A into G that we have got, A into G that we have got is 177.23 into 10 power 3. I am substituting the same, 177.23 into 10 power 3, which is equal to 16. Okay, sorry. We have changed the area, 0.008. This is the older area for 420.99 mm. Now we have changed the column size as 450 by 450. Now the area of gross area of the column will not be as the previous value, 177.23 into 10 power 3. It will be 450 by 450. So 0.008 into 450 by 450. Okay, so we get the answer as 1620 mm square. Okay, so find number of bars. So number of bars, which is equal to 1620 by pi by 4 into, so in this problem I'll be assuming 20 mm square, so you get 5.15, so I am taking it as 6 numbers. Okay, so you can take a higher grade, it should be minimum 16 mm, it should be more, minimum 16. Okay, maximum you can take up to 32, but make sure that you have a even number, not the odd number. Okay, so providing 6 numbers of 20 mm dia. Okay, once this is done, the next step is same. Okay, die of the lateral ties and the spacing of the lateral ties. So next is design of lateral ties. Design of the lateral ties. Okay, so first one 6 mm minimum. Okay, second one 1/4 of the diameter that you have used or that you have assumed. So assumed is 20, so it is 5 mm, greater of the two. Okay, next spacing of the lateral ties. Okay, so you have 3 conditions for this. One is least lateral dimension. So in this case, least lateral dimension, both B and D are same because it is a square column. Least lateral dimension is 450 mm. Second condition, 16 times the diameter that we have assumed. So 16 into 20, so it is 320 mm, and the third one, it is 300 mm. So in this case, least of the 3. Okay, so therefore provide 6 mm dia at 300 center to center. Okay, if you have any doubt, please text me through WhatsApp, and please study 7th problem and the 8th problem which I have given in the notes, and if you have any doubt, you can contact me. Okay, thank you.